Hello, Mr. Long. This is Evercare number 8, and it's a projectile motion problem. So part A asks to find the average net force on the ball during the kick. So to find average net force, you set net force equal to m times acceleration, the average acceleration. So A average is equal to the final velocity, Vf, minus initial velocity, which is Vi, over t, which is time. So net force is equal to m, which is 0.5, times Vf, which is 20, as given in the question, minus 0 because it says initially at rest, and divide that by 0.05 because that's the amount of time the ball was in contact with the foot. And when you plug this into your calculator, you get 200 newtons as the average acceleration, average net force. So B asks the time it takes for the ball to reach the plane of the fence. So to find how long it takes for the ball to reach the plane of the fence, we can set the function Vx times t is equal to 32, because 32 is the distance from the ball to the plane of the fence. So Vx is the same thing as V cosine theta times t, which is equal to 32. So V is given us as 20, and theta is 37, times t to 32. You can divide this over, and when you plug it into your calculator, you get about 2 seconds. Okay, C asks us to find the instantaneous velocity of the ball after it has traveled 32 meters downfield. So to find the instantaneous velocity, will be v squared is equal to v f x squared plus v f y squared. Then you put f. Okay, so vfx squared vfx is equal to vix because there's no acceleration acting upon the block. No horizontal acceleration acting upon the block. So vfx would be the same thing as the v as over here. And then vfy is equal to is equal to v I y minus gravity and times the time it takes for the time of the ball in the air. So VFY is equal to 20 sine 37 minus 9.8 times 2, and you multiply that by 2 because it takes 2 seconds for the ball to travel 32 meters downfield, and that gives you negative 7.56 m over s. So you go back into this VF squared is equal to V cosine theta squared plus VFY squared. You plug in your numbers, so it'll be 20 cosine 37 squared plus negative 7.56 squared VF is F squared is equal to 312.28. You square root both sides, and VF is equal to 17.67 m over s. And we also need direction, and to find direction, you take inverse tan you take the inverse tan of, right, to find direction, you set tan theta is equal to 7.56 over 20 cosine 37, and then theta is equal to tan -1 . And if you when you plug this into your calculator, you get negative 25.32 degrees. And the negative is the same thing as being 25.32 degrees below the positive x-axis. Okay. Part D asks if the ball will hit the fence, and if it does, how far below the top of the fence it will hit, and if it doesn't, how far above the fence it will pass. Wait, wait. No, the real part D asks if to find the ball's instantaneous speed after it risen 2 meters from its launch position. So to find it, to find the time it takes for the ball to rise 2 meters, set 2 is equal to VIY times t minus 1/2 a t squared. So 2 is equal to 20 sine 37 t minus 1/2 9.8 t squared, and if you simplify this, it'll be equal to 12 t minus 4.9 t squared. So you subtract 2 from both sides, and you plug in the quadratic solver to find how long it takes for the ball to reach 2 meters. After using the quadratic solver, you get t is equal to 0.17 seconds. So after you know that, we use the same formula over here, where VF squared is equal to V, or V, like after less than 2 seconds, VF squared is equal to VFX squared plus VFY squared. So VF squared is equal to 20 cosine 37 squared, because the horizontal velocity doesn't change at all, plus 20 sine 37 minus 9.8 times 0.17 squared. So this simplifies to about 16 squared plus 10.37 squared. So VF squared is equal to 363.5, and you take the square root, and VF is equal to about 19 m over s, and it's asking for speed, so I don't need a direction, and I just had to write this. So part E asks if the ball will hit the fence. So to find this, to figure out if the ball hit the fence, we know that the plane of the fence is what's it called? The plane of the fence is 2 meters, and the the plane of the fence is 2.5 meters. So the height has to be greater than 2.5 meters. So we know the time it takes for the ball to reach the fence or go past it is 2 seconds. And we know that the y formula is x is equal to y is equal to v I y t minus 1/2 a t squared. So y is equal to about 12t minus 4.9t squared. We plug in 2 seconds because we know that it takes 2 seconds to reach the fence. And y is equal to 4.4 meters, and that means that at 4.4, that means that the ball will go past the fence or over the fence because it's higher than where the ball is over here. So yes, wait, no, it'll be no, the ball will go over the fence. It asks how far above the top of the fence, so to find it, we subtract 4.4 minus 2.5, which is equal to 1.9, so it'll go over the fence by 1.5 meters. So part F asks to sketch the horizontal and vertical components of the velocity of the ball as functions of time until the ball reaches the plane. Okay, so to do this, we have to sketch the horizontal vx and vy as functions of time. Until the ball reaches the plane of the fence. So we need to graph it until 2 seconds. So we know that v cosine theta is about 16. So we can draw a line about here, which is slightly above. It's supposed to be linear, and stop that too. And then the Vy, we know acceleration is acting on it, so it means that the ball will decrease by 9.8 every second. So it starts at So Vy starts at about 12. And it goes down by 9.8 every second. And you just just draw a line right through them. It's supposed to be linear as well, but I can't draw a straight line, so yeah. So part F asks what angle should the soccer be kicked so it strikes at the bottom of the fence. So I know the range formula is equal to V squared sine 2 theta over G is equal to R. So the range is 32 because that's the distance from the ball to the fence, is equal to 20 squared, because the VI is 20, sine 2 theta over 9.8, and 9.8 is the gravity, so over sine 2 theta, so sine 2 theta is equal to 0.784. You take the inverse of it, do inverse sine, so sine -1 is 0.78 is equal to 2 theta. So you divide by 2. So theta is equal to 25.81 degrees. And that is question, and this is part G. And thank you for looking at this. This is all my work, and that's it.